In this video, we're going to cover what's called the Wye Delta Transformation, specifically Y as in like the letter Y to the Greek letter delta here. And what this is going to do is that we've seen before, sometimes you have resistors in series, sometimes resistors in parallel, but if they're not in series or parallel, there was no rule to simplify them. And there's nothing you can do at that point. However, with the Wye Delta transformation, you can take resistors that are not in series or parallel but happen to be in either the Y configuration or the delta configuration, and you can convert them back and forth. And again, the point of this is that when it's in the original form, nothing may be in series or parallel, but once you change it, they do become in series or parallel. And it's going to follow these rules here. It's unfortunately pretty annoying rules, as you can see here, but this is how it's going to work. And this third diagram on the right is just showing you, you could have this delta is equivalent to this Y here, and just to help you identify, but you're not having all 6 resistors at once. You're only having either the 3 blue or the 3 red. Now let's see how we can actually apply that to find an equivalent resistance. Now take a look at this circuit down here. That 13 ohm, it's not in series or in parallel with anything. The 24 ohm, not in series or parallel with anything. 20 ohm, 30 ohm, 50 ohm, 10 ohm, nothing is in series or parallel right now. However, if you look at it from the side here, I essentially have a T here. Now T is just a flattened out Y here, so we can go ahead and use that. And the way you're going to convert it is you can say, okay, let's go ahead and complete the triangle diagram here, because we're going from Y to delta. So the 3 blue resistors are going to be taken out, and the 3 red resistors are going to go in, but we need to figure out what they are based on their values. So if we look at this picture here for how Y delta is going to convert, so I'm trying to find the RA, RB, RC values, so I need to use these formulas. And if you look at the patterns here, so for RA, actually all of them, RA, RB, RC, they have the same numerator, which is the product of all the pairs of resistances. And then below it, you're dividing by a single resistor. And so RA is divided by R1. It's the opposite resistor here. Okay, so first off, let's find, we're doing RA, RB, RC. All 3 of them are going to have the same numerator, which is the product of all the different pairs of the resistors in blue here. So 24 and 20, 24 and 30, and 20 and 30. And again, that number is going to be the same number on top of all of these. And we just pull out our calculator and do a quick calculation here. 24 times 20 is 480. 24 times 30 is, 24 times 30 is 720. And then 20 times 30 is 600. And I got a total of 1800 on the numerator. And so for RA, I'll make it, this one's RA, let's say. So the resistor that's not connected to it is 30, so it's going to be that over 30 here. So 1800 over 30 is 60 ohms. That means this one is 60. We'll call this one RB here. So the resistor not connected to it is 24. So 1800 over 24 is 75 ohms. That goes right there. And the last one is going to be 180 over 20. And that's 90, so 1800 over 20 is 90. And so if I were to redraw my circuit now, I have this 13 ohm here. I'm going to have this 10 ohm and this 50 ohm. And then I have the 3 red ones. So one red one goes like this, and it's 60. One red one goes like this, and it's 75. And the last red one goes like this, and it's 90. At this point in time, once we've converted it, these two are now in parallel. So we have 60 in parallel with 10. 60 times 10 over 60 plus 10. That's going to be 600 divided by 70. Doesn't work out nicely. I'll go ahead and kind of leave it here. So 13 ohms. And we had 600 divided by 70 is 60 over 7. And then if I do the same thing for this bottom one, I have 75 and 50. That's 75 times 50 over 75 plus 50. That works out to be a 30 ohm resistor. And then we have this one here is 90 ohm. And lastly, we're going to go ahead, add up the 30 and 67s, those in series, and then we'll combine that with the 90 in parallel. Maybe I'll go ahead and take 2 steps just to do it carefully here. So 67ths and 30ths, well, 30 is the same as 210 sevenths, so it's going to be 270 sevenths. And when I do that in parallel here, so let's see here. I think this will actually work out nice, but we'll find out. 270 sevenths times 40 divided by 270 sevenths plus, oh sorry, it's not 40, it's 90. Let me fix that here. So 270 sevenths times 90 divided by 270 sevenths plus 90. And it's going to work out nicely to 27 ohms. See, I left it as a fraction because I had a feeling it was going to work out to be a nice answer. That's definitely not always going to happen, though. Sometimes you're going to just have to deal with decimals, and that's how it is. And lastly, 13 plus 27 together makes 40 ohms. And so that's our equivalent resistance here. So again, you can see having to deal with Wye Delta is definitely super annoying, but it lets you solve problems that otherwise would be impossible to solve.